Here's another video of Chapter 8 pre-quiz. So we're going to solve some triangles here. So if we're solving triangles, that means we have three sides and three angles. And Euclidean geometry, those angles add up to 180. So if I have two angles, one is at 42 and the other one's at 53, I could just add those up and subtract from 180. So I have 42 for this one. 53 for C. Now it really doesn't matter which angle is which, except for the fact that whatever the opposite side is has to be lowercase of that. Okay, so it really doesn't matter what label you angle is A or B or C. Just label the opposite side little a, little b, little c. And we have little a, okay? Then we want to use law of sines because here we don't have a right triangle, so we're going to use law of sines. Right, so therefore I always want to use what I have, right? So law of sines and what I'm trying to find. So first of all, like I said, we can just add these two up and subtract from 180 and we get 85 for B. So now I can really use B because I didn't round that, so it's fine. So I can use B as well. But first of all, I'm going to use what I have, so that'd be angle A and little a. And then I want to find these two sides. So if I want to find B, then I use law of sines that say B over sine of B, which is fine to use because it came out nice like that. And then I put in what I'm given, right? So I'm given sine of A, which is 42. And then I'm given the side of A, which is 125. So now I can just set this up. B equals 125 times sine of 85 over sine of 42. And I make sure my calculator's in degrees. I hit enter. And I get 186.1, somewhere about there, rounding it, of course. And then I can go ahead and set my next one. I want to find little c, so little c is on top. That means sine of c must be on bottom, which is 53, equals, I'm going to use what I'm given on both the angle and the side, so that'd be, again, a. I don't want to use little b here because I rounded that, right? So that's why I want to stick with little a of 125. And then sine of A, which is still 42. Make sure my calculator's in degrees. C is equal to 125 sine of 53 this time, all over sine of 42. So I enter that in my calculator. Maybe you got to be careful when you hit sine. It comes up with a parentheses, so close that off. And then close this one off. Right, if you want to be really careful, you can put the denominator in parentheses. And then super careful, you can put this in parentheses. All right, so then you get rounded 149.19. And so that's how you do law of sines. What I didn't do first is what I'll show you on the next problem. Is you got to sometimes, depending on what you're given. So here we're given an angle and two sides. So side, angle, side. And so where is that angle? Sometimes you can draw that out. Here we have our angle. Say this is A. This would be little a then. If this is C, this will be little c. So we're given an angle, side, or sorry, angle. Sorry, we're given two angles. Jeez, killing myself. Angle, side, angle. So that one's okay. There's no test there. In your book, you can find out what type of triangle you're trying to find, what you're given, and then it'll give the steps to what you need to do. Okay, so on this one, we're given angle, two sides, and an angle. So whenever we're given two sides and angle, if we spell that backwards, sometimes we get in trouble if we say that out loud. So there we have a possibility of two different triangles, and I'll show you there how you can figure it out. So first we're going to need to convert that to degrees, from degrees, minutes, and seconds to decimal degrees. So if we take 85 degrees and then 20 minutes, so 20 minutes, there's 60 minutes in 1 degree, so we just divide that. We get 1/3. So 85.3 repeating. And then we can go ahead and kind of enter that in our calculator. It'd probably be easier just to do the 1/3 would keep that because this keeps on going forever, right? So then we can go and set up our triangle. So first we have the two sides, 125 and 10. So it'd be nice to find the angle that goes with side C, because we do have angle A, right? But we don't have angle C. So if we can find that, that'd be great. So we set up law of sines. I want to find sine of C. So that would go on top. On bottom would be its side. Set that equal to what I'm given, right? Sine of 85.3 repeating, or 85 plus 1/3. And then over the side. So we solve for this. So sine of C is equal to 10 sine of 85.3 repeating all over 125. So if you just put 85.3, you might be off a little bit just because it goes on forever, right? So that's why it's best to just do 1/3. And then to find the angle, what do we do to find the angle? That's when we do inverse, right? So C is equal to sine inverse of this. And then I can enter that in. I get 4.57. So if you get a little bit something a little bit different, that's just because you might just did a 0.3 instead of 0.333 or 1/3. Okay. So now I can go ahead and add those two angles up, subtract from 180, and I get 91.1. Okay, now to figure out if there's a second triangle, what I need to do is sometimes it's best to draw it out, right? So now I have, okay, this is angle A, I have that, and then I have angle C, so this would be little a, this would be little c, and then this would be angle B, of course, and this would be little b. Okay, so if we have 125 for angle or side A and 85.3 repeating, and then we find this angle C, and we know this little c, right? So sometimes what happens is we find this one right here, 4.57, right? And then we're able to calculate B. Well, sometimes this side C might be looking like this, where it cuts through here, and this is actually same as 125, so that's A as well. And then so see how we have this little triangle here. We still have C, side C, we still have side A, and we still have angle A, so we're still given what we're given, but we have this interior angle right here. Well, we know that if these two are the same, that means their angles would be congruent, right? So this would be 4.57. So if I want to find this, what we call a new C or C prime right there, then we would have to take that and subtract it from 180. So 180 minus 4.57. And so when I do that, I get what? Something around 85, right? I'm just, somewhere around 85. Well, if that's 185, well, subtract it, 175. 175. So if that's somewhere around 175, right, and this is 83, then this B prime right here would not be 90, right? Because it's 175 plus 85. This would not be a triangle. So there is no second triangle here. And that's how you figure it out. So you find your first angle, and then you subtract that angle from 180, and then you see if that angle is combined with the angle that you're given. Is that greater than 180? If it is, then you don't have a second triangle. And then so we can keep with our first triangle and finish that out. So all I need to finish that out is right here at side B there, right? So I can set up B given the angle 91.1, and then set that equal to my original, what I'm given. I don't want to use C because I had to round that there. It's okay here, that's fine because I have to use that. And then sine my original, and then over that side that's given 125. And then I go ahead and multiply that out, and I get 125.39. Okay, so that's how you test for a second triangle. All right, so here we go again. So this one, set up what I'm given, 145, so angle and two sides. So here I'm given an angle and two sides. Whenever I'm given an angle and two sides, right, then I have something special going on. So 145, and then 5.8, and then 4. So I want to find this angle first. So remember, that's when I do inverse, but I can go ahead and set it up. And then the angle that I'm given over the side that I'm given. Okay, and then I can just solve this, and I'm going to take the inverse. Make sure I'm still in degrees, so that means my calculators need to be in degrees. So I'm going to take sine inverse of this, and that's going to give me angle B. And so then angle B is 23.3 about. All right, so then I can subtract, add these two together, subtract from 180, and I get 11.7. And now I need to just check my second triangle here. So in that, this angle that I found, the first angle that I found, I'm going to subtract that from 180. So 180 minus 23.3. Okay, and that's 56.7, or 156.7. And then I'm going to add the original angle that I got, 145. And because that's bigger than 180, I'm not going to have a second triangle. Okay, if it's less than 180, then that will give me my this subtraction right here is going to give me what that B is. C will be the same at 145, so this would be 156 if it worked. And then this last one would be whatever this adds to. I would subtract that from 180, and that would be this last angle right there. All right, so then I just need to find a little a, so I don't have a second triangle, because that doesn't, these two together would not add up more than 180, right? So it's not going to work. This would be some kind of negative angle, which can't have. Okay, so now I just need side A, so I set up that. Sine of 11.7 equals the original that I'm given, so sine of 145 all over 5.8. So I set this up and I solve it, and I get 2.05. Okay, so I'm given a angle and two sides, therefore I might have two triangles. So I set this up. I have 20.5 degrees and the side that's given, so that's what I'm going to use, right? And then what I'm trying to find, I'm given side C, so that means I want to find angle C first. Set this up by taking the inverse. All right, sine inverse of 31 times sine of 20.5 all over 12. And so for C, I get 64.78. Somewhere about that. Okay, then I can subtract. I can add those two together, subtract from 180. Excuse me. And get 94.72. So I'm going to take this angle that I just found by taking the inverse. Okay, that one is the one I subtract from 180. So I subtract that from 180. Okay, and that gives me my C prime, or my C for my second triangle. Okay, and so that's 115.22. So 115.22. Now I need to see if I get a second triangle. So I'm going to take this angle, the angle that I'm originally given, which is 20.5, add those two together. Okay, so that's 135.72. So you notice that is less than 180. So I'm going to subtract that from 180, and that is going to be this angle A. So I subtract that from 180, and I get 44.28. So how you know, yeah, you have a second triangle, is this always adds up to 180, right? You can't have a negative angle. So if this is negative, then you're not going to have it. All right, so then I can find my original sides that I was given. Those are the same ones that I was given here. Okay, so you notice that this part's the same as this part. This part is the same because those are all the three things that I was given. Okay, but I have a new angle A and a new angle C. All right, so now both of these I just have to solve for side A, right? So for the green one, I have little a over sine of opposite angle equals the original that I'm given, so B and B. So little b is 12, and then sine of 20.5. So then I solve for this, and I get 34.15. 34.15. All right, then the blue one, I want to do the same setup, 12 over sine of 20.5. So this is 20 0.5 equals little a that I'm trying to find, it's the last one, and then the sine, now it's sine of 44.28 of the second triangle. So then I solve that and I get 23 point, this is either a 9.2 or a 4.2. I'm thinking it's a 9.2, but it might be a 4.2. I can't read my own writing. Okay, so that's how you solve for two triangles. And that only happens when you have an angle and two sides, where the angle is not in between. So notice that if you draw this out, if this is B and B, they're across from each other, but C is not, this angle is not in between. So if C is here, little c would be here. So you notice this angle is not in between. Anytime the angle is in between the two sides, then it's okay. You won't have two possibilities. It's only when the angle is not in between that you always have a possibility of no triangles, one triangle, or two triangles. All right, so this one we have three sides. All right, so on this one I'm given three sides. So whenever I get three sides, I'm going to use the law of cosines to find one of them. So I'm given A, I'm given B, and I'm given C. So I'm going to use the law of cosines to find angle A. And then once I find that, use the law of cosines, I'm going to use the law of sines to find angle B. And then I'll add those up and subtract from 180 to find angle C. So law of cosines, if I want to find angle A, that means I'm going to be eventually taking the inverse. But that one I'm going to add the two sides that are not opposite of the angle I'm trying to find. So these two sides are the opposite, or these two sides are the sides, not the side opposite of the angle I'm given. That probably didn't make any sense. But anyways, I'm going to square every side. Okay, so I'm going to square them all. And then I always just subtract the opposite side of the angle I'm trying to find. The other two I'm going to add. Maybe that makes better sense. And then on bottom, when I divide, I'm going to take 2 times the two sides that I added, right? Okay, and then I'm going to take the inverse of this, or cosine inverse, sorry. So cosine inverse of this answer. Okay, so you might be careful here. Just put the numerator in parentheses, put the denominator in parentheses if you want to be careful. All right, but you should get here for angle A, you should get 31.98 approximately. Okay, and now I can use that. And now I can find sine of B. Again, I'm finding an angle, so now I'm going to do inverse, but this time inverse, I'm going to do sine. Sine of my angle that I just found over its side. And now I can go ahead and solve that. And I get 42.38. Now I can add those up and subtract from 180, and I get 105.64. Okay, this one I'm given an angle and two sides, so an angle and two sides. But here, if I draw this out, I have angle and the two sides, so this would be little a, right? And if this is B, this would be little b, and this would be C and little c. So that means that I'm given this angle, this side, and this side. So notice the angle that I'm given is in between those two sides. So it's actually side, angle, side. So that means I'm not going to have two triangles or no triangles. I'm just going to have one. Okay, so sometimes it's best to draw it out so you know if you do a side, angle, side, or side, side, angle, and side, side angles when you have 1, 0, none, 1, or 2. Okay, so now I can just set this up. I want to find little a first, right, because I have that one, so I want to find its opposite side. And I'm probably can't right now because I just have this side and I have this side, right? So I have no, on the other one you notice that if I was given an angle, it's given the opposite side. Well, here I'm not, right, with side, angle, side. So that means I have to use law of cosines to figure out what these are. So this time I'm actually going to find this third side first by using law of cosines. So I can find that by using law of cosine. So I'm going to have to square root both of these. So I'm going to square root this. So I'm going to do b squared the two sides that I'm given, I add those together after I square them. Then I subtract 2 times B and C, the two sides that I'm given, times cosine of the angle I'm given. Now this angle will change based on what side I'm trying to, so if I'm trying to find side B, this would be B, this would be B, right? And then this would be C and A, C and A. All right, so I go ahead and calculate this, and I square root them, and I get 13.14. 13.14. Now I can go ahead and do law of sines. I can find sine of B by using side of B, and now I can use sine of A that I just already given, and then the side that I found with the approximation of 13.14. Now I go ahead and figure this out, and I get 12.43. Then I can add those, subtract from 180, and I get 32.57. And so that's how we solve triangles there. Okay, so here we're trying to find the area of a triangle whose sides, we have all three sides, so we're going to do Heron's formula, which is 2 parts. If we want to find the area, then we square root this S, where S is the semi-perimeter, or just adding up all these 3 sides and then taking half of that. So it's the semi-perimeter. Here the perimeter would just be adding those, right? So semi would be taking half, okay? And then each side minus that semi-perimeter, and then times those together, and then square root it. So you got to find this S first, which is adding all these up, and then dividing by 2. Okay, so we add them all up and divide by 2, and we get 11. So I can put that in my formula. 11 times 11 minus my A times 11 minus my B times 11 minus my C. And I take the square root of that, and I get 16, that's my area. I get 16.25. Okay, here I have a triangle with a side and angle, or sorry, side, angle, side, side. So in order to use the formula here, we have to use law of cosines in order to figure out what the little c is, the third side, and then we can use that same formula above. So here, law of cosines, I'm finding c, so that means I need little c squared, so I got to square root both of these. And so that is the 2 sides that I'm given squared, added together, minus 2 times those 2 sides, times cosine of the opposite of the side I have, the angle opposite of the side I have. So that'd be 84.30. Okay, so I calculate what that is. And I get 24.39, so that's little c. Then I go ahead and calculate the semi-perimeter, add those up, 16 plus 24.39 plus 24, or sorry, plus 20, and divide that by 2. So I do that, and I get my semi-perimeter as 30.19, and then I can go ahead and do my area is that answer. So 30.19 times 30.19 minus 16 times 30.19 minus 20 times 30.19 minus my 24.39. And I square root that, and I get 159.2 approximately, so you should be somewhere close, maybe 2.6, depending on how you round it. Okay, and so that is our area. All right, converting to trig form. First, we find our radius, and that would be taking our A and our B, so that A would be 1 and B would be negative root 3. And then go ahead and use Pythagorean Theorem, square those, and add them together and square root it. So 3 plus 1 is 4. Square root of 4 is 2. So r equals 2. Then I found my theta, which is tan inverse of our b over our a. So what's square root 3? That would be pi thirds, which is 60 degrees. So you can do it in degrees or radians. So either pi thirds or 60 degrees would be our reference angle, but we want a negative tangent. And so since we want a negative tangent, that would be in the second quadrant or the third quadrant. To determine which one, if we graph this, we go over 1 and down root 3, so we're in the fourth quadrant, so that would be 5 pi thirds or 300 degrees. Oops, 300 degrees, not 3,000. Okay, and so then we can write our in trig form or polar form, our radius times cosine of 300 degrees or 5 pi thirds plus I sine of that same angle. And that's how I write it. Okay, convert to complex form or rectangular form. Either of those are the same. Basically, all I do is just solve this. What is cosine of pi 6, right, of 30 degrees? Cosine of 30 degrees is root 3 over 2. I guess I should write that up here, root 3 over 2. Sine of that same angle would be 1/2. Times that by I. So I get I times 1/2 is just I 1/2. And then I have 6 on the outside. I just distribute the 6 to both of those. So I get 3 root 3 plus 3I. Done. So that seems a little bit easier. All right, de Moivre's theorem just says if I want to take a complex number to n power, right, I can just rewrite that as r to the n. So that would be our radius to the n. So we got to find our radius. So we square these, our a and our b. So I square root 2, I get 2. Square root 2, square root 2, I get 2. Add those together. Take the square root. Right, so there's our r. So our r equals 4. Our n equals 6. That's our exponent. So we get 4 to the 6th, which is 64. Okay, and then we just do our theta, our angle, which is tan inverse of b over a. And then again, we can graph this to find out which quadrant it's in. So root 2 somewhere, root 2, so I'm in quadrant 1. So what is tan inverse of 1? Because root 2 over root 2 is just 1. So tan inverse of 1 is just 45 degrees. So our angle is just 45 degrees. So this would be cosine of 45 plus I sine of 45. And then I can just go ahead and solve this. One quick correction, I got to times this, my angle by my n. So that'd be by 6, my angle by my n, so that's 6. Sorry about that. So I get 270. So I'm going to find cosine of 270 plus I sine of 270. Okay, and cosine of 270 is just 0. Sine would be -1, so negative I. And then times by 64, so it'd just be 64, negative 64I. Sorry about that. So his theorem is this. R to the n cosine n theta, missed that part, plus I sine n theta. Oops. N theta. Okay, so that's de Moivre's theorem for finding powers. Then his theorem for finding going backwards, we just want to go backwards here. So here, when we're just going backwards, really we're taking this to the 5th, so that'd be 2 to the 5th times this in parentheses to the 5th, which is de Moivre's theorem, so it's 2 to the 5th, then just cosine of 5 times 6 degrees plus I sine of that same answer. So that'd be 30. All right, so that's 30. So then what's cosine of 30? That's root 3 over 2 plus I times 1/2. And 2 to the 5th is 32. So we multiply that, we get 16 root 3 plus 16I. Okay, so that's pretty easy just using that theorem. All right, so this one's the hard one. We're using his theorem again, this time to find all fifth roots. All right, so to find all fifth roots, that would mean my k's are starting at 0, 1, 2, 3, and 4. So we got to find our theta, which is kin tan inverse of our b over our a. Our a is this time 0. So where is tangent undefined? Well, tangent is undefined at 90 degrees or at 270 degrees. So if I graph this, that's just going to go down 32, right? So we're in our theta would be 270. So that's our angle 270. And now we got to find all our alphas, right? For K0, K1, K2, K3, K4. And alpha is our theta over our n, and our n is the fifth root, so that'd be 5. So our theta is 270 over, our alphas is our theta 270 over 5. And then we always are going to times that by 360 times whatever our k is, right? And that's all over our n, 5. Okay, so that's how we find our alphas. So I'm going to plug in 0 for k, and then I'm going to plug in 1, then I'm going to plug in 2, then I'm going to plug in 3, and then I'm going to plug in 4 for all my alphas. So my alpha 1 is just going to be 270 over 5. So I just take 270 over 5 to find all my alphas. So let's see here, 270 over 5. I get 54. And then I want to plug in, so then I'm going to plug in 1. So that's 270 plus 360 divided by 5. I get 126. So alpha 2 equals 126. 126. So each time I'm just changing this. So changing it to times by 0, so that'd be 0. And then this is addition here, sorry. So that's 270 over 5. Then I'm going to plug in 1, so that's 360 plus 270 over 5. Now I'm going to plug in 2, so that's 720. So 720 plus 270 divided by 5. I get 198. So that's alpha 3. Then I want to erase that 2 and put in 3. So 3 times 360. So 3 times 360. 1080 plus 270 divided by 5. My n is 270. So alpha 4 is 270. Then I plug in my last k, which is 4. It's always 1 less than your n. So I plug in 4, so 360 times 4, 1440. And I add 270, my theta, and I divide by my n, which is 5, and I get 342. So my last alpha is 342. Okay, so then I can go ahead and use his theorem now that says, okay, now I can go ahead and plug this into trig form or polar form. And it's the nth root of r, which is times cosine of alpha plus I sine of alpha. So that means I'm going to have it 5 times, right? So I plug in my r, do my n, I can do that on the side, right? So because I know my r is the distance, right? So from 0, or I can use Pythagorean Theorem. My a is 0, so 0 squared plus negative 32 squared, square rooted, that's my r, so r equals 32. And then the fifth root of that, because I'm going to do all fifth roots, so back to 2. So I know that answer. Now I can just do all my alphas. So 54. So what's cosine of 54? I type that in, or I can just write these answers just like this. So 2 times cosine of 54 plus I sine of 54. So I can just type that in and get it, but I think it wants it in trig form. Yeah, in trig form, so I can just leave my answers like that. Then I plug in my next alpha, which is 126 plus I sine of 126. To cosine of my next 198 plus I sine of 198. And then next one, cosine of 270 plus I sine of 270. If it wanted in rectangular form, then I would have to type in cosine of 54 and see what that decimal is, and then do sine of 54, see what that decimal is, and then multiply each decimal by my r to my nth root. Okay, and the last one, cosine of 342 plus I sine of 342. Okay, and so there's all the fifth roots of that. So this one's the more complicated one. Okay, now a ship is traveling, so you have some kind of ship. It's traveling due west from a port, 91 miles. So here it is, leaving port, going due west for 91 miles, and then switches directions, goes northwest in a direction, 41 miles. So northwest would be like this, correct? For 48 miles, and then it ends up from the starting point. So here's my ending point. Starting point is 117 miles away. So really I just have a triangle here. This is just some angle. And I have three sides of a triangle. How many degrees did it change in direction? So it wants to know this angle. Well, I have three sides. So if I have three sides, how do I figure out what angle it is? Well, I use law of cosines. So law of cosines, I want to figure out what this angle is. I take the two sides that that are not opposite of the angle that I'm trying to find. So the side opposite of the angle I'm trying to find is 117. So I would subtract that from the other two squareds, which are being added together. So I'm going to square all three sides, but subtract the side opposite of the angle I'm trying to find, divided by 2 times those two sides that are not opposite of the angle I'm trying to find. And then since I'm doing cosine, I would do cosine inverse of this, right? So I'd do cosine inverse of that, and I would get 110.81. And so that's the angle, because I'm in degrees. And it's asked for degrees, so my calculator's in degrees. Okay, this one, same thing. Okay, T on a golf course. T on a golf course. And the course is 335 yards to the hole. So here's the hole. Here's the golf ball. Trying to get in the hole. The guy hits that drive from the tee at 275 yards. So he hits it somewhere. It goes 275 yards at an angle of 19 degrees. So it goes 275. And then we want to figure out how far the ball is away from the hole. So he just hits it. So we want to find out what this side is here. So we're given an angle and two sides in between. Or sorry, yeah, two sides and an angle in between. And so we can use, again, we can use law of cosines. I want to find b. So it means I'm going to take the square root of it, because normally this is b squared, so I have to square root it. And the two sides that I'm given, I square those, add them together. Subtract 2 times those two sides. Move this a little bit for you. And then times cosine of the angle I'm given. All right, and then so I get 116.78. Okay, so there's that one. Real quick clarification, right? So here's straight to the hole, but you know, as golfers, you're terrible. So he hits at 19 degrees this way of the hole, so he lands somewhere out to the left, right? 275 degrees. So hopefully that makes sense. He could have hit it straight, but he didn't hit it straight. All right, multiply and leave your answer in a plus bi form, exact values for a and b. So basically, all you're doing is just simplifying these, basically. So we want to multiply them, right? So what's nice about multiplying in polar form is we can just multiply our r's and then add our thetas. So we just multiply and we get 12. And then we can just add our theta, so pi 12ths plus pi 4ths. This would just be 3 pi 12ths, right? This would be just 3 pi 12ths. So really that's just 4 pi 12ths. So cosine of 4 pi 12ths, which is the same as right? These two angles are the same, right? So I'm going to reduce this second one. So 3 pi 12ths is just the same as pi thirds, right? So really these are just both pi thirds because these angles are all the same. All right, well, what's cosine of pi thirds? Well, cosine of pi thirds is just 1/2, and this is root 3 over 2 times I, which would be I, so root 3 over 2I. Then just distribute your n, so that'd be 6 plus 6 root 3I. There you go. So it seems complicated, but really it's not too bad. So when you're multiplying, you just multiply your r's and add your thetas, and then just find out what cosine and exact values means. Don't use a calculator. Okay. All right, so that I believe is it for you. So all done.